Good afternoon, DevSecOps enthusiasts. Welcome to our final and third part installment of DevSecOps OpenShift Red Hat. We started about 2 weeks ago with John Keem, a hybrid cloud solution architect from Red Hat, taking us through an overview of DevSecOps and talking about the benefits of Kubernetes and containerization. Last week, we followed that up with a day in the life of operations, and that was our 102 session of this series. And today, we wrap up with our final session, 103, a day in the life of the developer. And so we're going to kick it over here to John Keem here and to talk us through and provide the presentation. As we've done on the last two sessions, we'll have a question and answer period at the end, and we look forward to diving in. So over to you, John.
All right, thanks for that. Yeah, I had a lot of fun the first two sessions, and I'm really happy to be back here. Like Mark had talked about, the first session we talked about OpenShift. The second session we talked about how that impacts the life of an operator, and today we talk about how that impacts the life of a developer. A particular interest of mine, being a developer background. So again, thanks for having me here today. My name is John Keem. I'm a hybrid cloud solutions architect here at Red Hat. And like I said, today we're going to be looking at how the DevSecOps movement, what that impact has had on development, and see how OpenShift makes development easier, and how with OpenShift, you're able to build a trusted software supply chain. We'll get into what that is, and we'll see how we can get our code out from our workstations on our personal development environments out to our end users and constituents and really add value. Okay, let's get rolling here. So real high level, this is what we're going to be talking about. We're going to be looking at the world through the eyes of a developer. Don't worry, it's not too scary. We're going to see the changing landscape and see how the world has started to shift underneath their feet, even if they don't know it, but they probably do know it and are feeling it. See how OpenShift can come in and really help kind of alleviate some of those things and help developers keep doing what they're doing in a better way, specifically with some of the OpenShift tooling, developer tooling, which we'll look at. We'll talk about this idea of a trusted software supply chain. We'll take a look at these weird words called red sword and dead sword. You're probably already familiar with dead sword, but we'll talk about that and assume that you've never seen it before. And lastly, we'll just kind of wrap everything up. All right, so with that, let's get going. So if you're a fan of this series, you'll probably recognize this diagram here. I've shown it the past couple times, but I really like it because it demonstrates how it impacts each of the various groups within an organization and really shows in a nice way the problem that exists and kind of why a lot of organizations aren't able to move as fast and as quickly as they'd want to. So when I say traditional development, what do I mean by that? Well, it's the idea that these highly functional teams kind of get created as a result of people working together and are doing kind of the same role and the same capability, or producing the same capabilities. And as a kind of a way that humans kind of work, they clump together and start to form these natural groups. That's not in itself a problem. Having a highly functional team that can do a thing really well is not a problem. But when you need to work together, you need to be able to have the process in place and the right culture in place and the right technology in place to enable that to happen so that the entire team together can really propel themselves forward. Okay, but we're talking about a world here that developers are familiar with now, where the technologies move so quickly. The hot technologies today weren't necessarily hot technologies yesterday, and there's so many things to continually learn. It feels like it's just trying to keep your head above water. But at the end of the day, what we're trying to do is we're trying to move faster to be able to meet the needs of our customers and to be able to continually provide value and bug fixes and keep up with the pace of innovation and the demands of our customers. So adding on to that, the organizational pressures beyond just thinking about what the developer has to do, but the concerns and the mandates that the organization sets down. It's all these things put together that put a lot of pressure on developers to make sure that they're able to build and move as quickly as they need to, all safely and all securely. Okay, so this is a definition I really like. I showed it last time, but I like it a lot for a piece I'm going to highlight here. But working together seamlessly and effectively is, again, the only way that we can really hope to achieve all the things that we want to achieve. And this is exactly the idea behind that DevSecOps movement. So this particular definition is from the Red Hat definition from DevSecOps. You can see right on our website. But I like this definition especially And I'm going to read it a bit here. Teams communicate frequently and approach their work with empathy for their teammates. And that's exactly what this series has been all about. Learning not just about Kubernetes and OpenShift and the particular technologies, but also about that cultural shift and that mindset change that goes into embracing a DevSecOps mentality. And all of that starts with empathy, which is why last week we looked at the world through the life of an operator. And today we're looking at the world through the eyes of a developer. So a developer or architect has a number of competing demands that they all need to meet. Traditional wisdom says that you can only achieve 2 out of 3 of these, but really in the modern era, that's unacceptable. You need all 3. End users demand all 3. And this is the challenge that the developer / architect faces: how to build applications that satisfies all 3. Okay, so let's go through a little bit here. The first thing a developer or architect thinks about, well, is the architecture. What will the system run on? Where will it run? How will it run? At a 1,000-foot view, how does the application or applications work? How are they connected? How do they communicate? Are you building your house on the solid foundation? Now, moving to the next quadrant here, we look at the next big concern, which is how do you deploy your application and keep them running? How do you deal with performance issues? How do you spot and perform root cause analysis on bugs? How do you perform upgrades of your applications? A lot of the concerns the developer would work closely with the operations team in order to solve. And lastly, the development, the actual writing of the code. How does the developer write code? What does their environment look like? What tools are they using? What languages? What frameworks? What are the processes around writing tests, code reviews, running tests? A lot of questions. There are a lot of concerns that a developer needs to constantly keep considering and weighing throughout their day at their work, at their job. And added on to that, there's a whole plethora of tools that are available, and they keep coming out seemingly every day. I remember when Hudson CI used to be the best build tool. These days, Jenkins has kind of taken over his job. And maybe there's another build tool you like that's taken over Jenkins' job. I remember working on a Cold Fusion app and writing SQL right in the presentation layer, thinking this is the way to do it. That was in the dark ages before we knew better. I've also worked on applications written entirely in Golang and serverless functions. So despite the huge differences in applications and approaches and concerns, the point I'm trying to make here is that no matter what language or team, the needs and motivations for the developer was the exact same. Let me use the tools that I ultimately want to use in the way that I want to use them. And if you have a new tool for me, make my life easier and not better. All right, not worse, not harder. All right, so if you're a developer out there and you face a mountain of process and seemingly endless, pointless meetings, you probably had this thought at least once in your life. I know I've had it multiple times. Frankly, developers and operations and security professionals all want to be able to focus on their tasks, collaborate effectively within and between teams, and have all that boring stuff automated out of the way for them. Especially given the myriad of tools, if I don't interface it, I just want it to work and I want to have it automated right out of my life. And if there's a tool I use or I love and I'm passionate about, I would really love to use it in my day-to-day. And if there's a new tool, like I said, it better make my life easier, make things more efficient for me, not make it harder, not make it more confusing, not make things more complex. So I talked about writing that Cold Fusion app. Needless to say, things have changed since then. Writing microservices or serverless applications wasn't even a concept I could fathom back then. But even if you aren't writing microservices, though, the demands we spoke about earlier, speed, scale, stability, in addition from external factors like cost, are changing the ways we write and deliver applications. What is a developer to do? Let's look at the current state of application delivery. If you're like most of our customers, you have a crazy mix of new and old, and when it comes to the applications, that application that you need to run within your organization. Most large enterprises have a huge existing app portfolio that are built with traditional architectures, maybe monoliths, N-tier applications, ESBs, and traditional languages like Java or .NET or maybe C++, or maybe even mainframe. In addition, you might have new apps or modernization efforts where older apps are using newer languages and frameworks. Maybe you're starting to use Spring Boot or Quarkus or Micronaut or Node.js or Golang. Many of them are now moving to integrate even more intelligence and newer models into the applications. Like maybe you're introducing some improved or new analytics, AI, ML, event-driven architectures, some serverless functions to do some quick one-off processing things. So how do you, thinking about it yourself, looking at this diagram, what do you have in your portfolio and what sort of challenges can you think of where you're trying to have all of this work together to still provide value and not just be lost in all this? What do your development process look like? What are the methodologies to build all of these different types of applications? In addition to adding adding support to your old applications that maybe they were built in the waterfall methodology days, how do you implement CI/CD and a DevSecOps methodology to those old applications? And you need to provide, you have a mix of skills potentially that various different people are using and working on. How do you get all of those different people to work together and to be able to adapt to these changes over time? This born in the cloud approach that a lot of companies are now embracing, how do you work that into your existing workflow or with your existing processes and things like that? Okay, so where you are trying to run these applications really matter. Is it on the cloud? Is it on-prem? Is it on bare metal servers? Is it in virtual machines? Well, again, if you're like many of our customers, you're probably already using multiple clouds or looking at it, in addition to your own private cloud and your own data center, and very likely on bare metal and at the edge. So your infrastructure in a lot of ways are already hybrid. Do you have an architecture that is flexible enough to be able to support this hybrid methodology? And how do you move faster with that stability and scale that you need in that crazy hybrid mix of applications, processes, and infrastructure? How do you help your development, your architecture, your operations team, security teams all work together to effectively deliver software with speed, stability, and scale with consistency across your hybrid environments, from your bare metal to your public cloud to your edge to your multiple clouds? How do you provide flexibility and consistency to allow teams to be able to effectively, efficiently build and run the software where it is best suited to be run? So Red Hat believes that the open hybrid cloud can help you do all this. Red Hat has that vision and has had that vision for a number of years, nearly 7 years now. We think that open hybrid cloud is the best way to be able to architect, develop, and operate a hybrid mix of applications. Not really pigeonholing yourself into one particular cloud vendor or pigeonholing yourself to one particular set of technologies, but instead embracing this hybrid open model where you can have the freedom to choose the best tool, platform, right cloud for the right job, or the not being locked into any specific solution. And we love the idea of open, embracing that open standard or access and stability to that open source community, getting access to that innovation and be able to swap things out as needed, all based on that open standard. Okay, so talked about OpenShift here. Talked about Red Hat, talked about OpenShift. The OpenShift advantage, what exactly does that bring to all the questions that I raised, and how exactly can we apply that? So if you've been a fan, like I said, of the past two series, I've talked a bit about the OpenShift advantage and about the DevSecOps platform that really enables developers, operations, and security teams to all collaborate and work together on the same platform, which we believe really enables DevSecOps. We want them all to work together. It's just really beneficial. The entire organization can work together on the same platform and collaborate together. And this is something that Kubernetes or some other container orchestration project can't offer you on day one, because there are so many added features and missing functionality that you get with OpenShift on day one. So being a developer, I'm super excited to talk to you about all the developer-centric tools today, as well as this automated pipeline that brings together DevSecOps into something we call the secure, trusted software supply chain. Okay, so you might have seen this before. In the last few sessions, we talked about how containers really enable that DevSecOps movement, how the proliferation of containers required a more sophisticated way to manage them. And we've talked about how Kubernetes is the most popular container orchestration tool, but how Kubernetes stops short of a full enterprise solution. So you can see here, I really like the slide because it concisely answers that question of what is the difference between Kubernetes and OpenShift. So you can see Kubernetes in there, but I'm going to quickly recap the other layers. So starting at the bottom layer, we have the run almost anywhere, physical, virtual machines, on-prem in the cloud, even on smaller footprints in the edge. And the next layer above that is, running on RHEL, our rock solid operating system. And then the Kubernetes layer, which is where you can orchestrate the various containers that you need to run and have a way to manage them. And then on top of that, we add service. We make that even easier to manage, the Kubernetes piece, like over-the-air updates to be able to easily and quickly update Kubernetes itself, as simple as an easy button click. We add an easy way to add persistent storage or image registry right out of the box. And then right on top of that, we add even more services, which we've talked on before, but today we're going to see them in more detail because a lot of them are really developer focused. We have the developer services there as one of them, but in a lot of ways, all of these really help a developer do their job. So we have platform, application, data, and developer. So the platform side enables developers and architects to be able to have sophisticated architectures at their disposal. Things like service meshes or serverless capabilities, native CI/CD pipelines. We're going to touch on all these things. Next, application services. Number of runtimes for your applications, like OpenJDK, or tooling around the API lifecycle management, or business process automation. We're going to touch on all those today too. Data services like distributed caching layer or AI/ML pipelines. Bunch of things. Data is critically important. You don't want just data to disappear. A lot of ways represents the value that your organization has captured, collected, created. So data is ultimately super important. And then developer services, the developer-centric tools that a developer potentially would be using every day, like code-ready workspaces where they get an IDE right in the cloud, or their own local developer sandbox they could use and play around with things, which again, we'll touch on all that stuff. And lastly, at the top is the multi-cluster management. If you have multiple OpenShift clusters, it allows you to manage all of them in one single place. Okay, the easiest way to provide everything developers need in an open development platform is really to start with OpenShift, Red Hat OpenShift here. Red Hat's award-winning enterprise Kubernetes-based application platform, which builds on Kubernetes and adds all the capabilities needed for a full application development and developers and operations to work together. It includes Red Hat's application services, data services, technologies, and the result is the consistent platform that runs on any cloud and empowers developers to build applications to support the business at the speed demanded by their customers and by the organization. Okay, so now at this point, I kind of generally talked around things, but you might be asking, what specifically are the tools? What does OpenShift give me? What can I use? How can I play with this stuff? Great question. Let me show you. So all these features that come with OpenShift mean an enterprise-ready platform on day one. But for specifically a developer, there are very specific features that come right inside of OpenShift that make everyday operations and the workflow of a developer easier, not harder. So today we'll into some of these. We've talked about some of them today as we get through it. You saw the last session about the operations side, but that's because developers and operations, they work so closely together that a lot of these functions and features, you can't really separate the two. But we'll dive into it from a developer-centric point of view. So now let's look at the specific tooling that OpenShift includes that are specifically for the developer. After that, we'll see how everything can work together and create a secure, trusted pipeline to deliver code that's tested, secured, packaged, and deployed so your users can start benefiting. So a quick story here. I remember on one project, I worked for an agency. I won't mention which one. I got my desk on the first day, so I had a place to sit, but I definitely did not get a computer. It was a really long process to get it provisioned and to get all the tools that I needed approved and installed. I wanted to get started, but there wasn't much I could do. I remember being given a huge binder that described the statement of work and the high-level processes and phases of the projects that we would be undertaking over the next couple of years. Here, read this in the meantime, is what they told me. So while this 2,000-page document was a riveting read, I actually had quite a bit of good information in there. I was in this weird holding pattern for weeks. I was brought in to help write and design software, and I couldn't wait to get started. So I figured I'd walk around and, well, I tried to schedule meetings first with my coworkers to start having them walk me through the code base, but I didn't have even a way to check email. I couldn't see other people's calendars. I couldn't schedule meetings. So I ended up just walking around to people's desks and bugging them with my notebook and pen and writing things down. Most people on the team were extremely busy, particularly the leads. So this process was super tough. Now imagine instead of that, imagine if there are no tools to install. Imagine I was given a secure, very bare bones laptop where all it had was a browser that I could open up, connect to the internal network, and I could start developing immediately. That internal website, potentially, theoretically, would look and feel like Visual Studio Code, if you've ever used that before. And theoretically, all of my code that I'd be working on would already be pre-installed, as well as having the language runtime like Java or Python or whatever it is, already installed with an interactive terminal that I could just start working, building code, deploying it right there inside the cloud and testing it. And imagine if every day you started your workday that way, where you would just open your laptop, go to this secure website, log in, and start cracking. So this is exactly what Code Ready Workspaces is. It's this development environment provisioned by OpenShift, which means that your environment is actually inside of OpenShift, inside of a pod, inside of a container, backed by persistent storage. So of course your work isn't lost. But that workspace would be configured and secured by your security team and your operations team. And it would be just minutes to spin up for any new developer coming on board. So that's what Code Ready Workspaces is. Really cool, really powerful thing. Okay, now what about special tooling? Let's say a part of the app that I'm working on, I need to pull in a database or something. Now, of course, I could create a Docker file and deploy a database or something that way. Or I could use this thing called Docker Hub. So Docker Hub is a marketplace where a developer could search for applications that they would use, like a Postgres database, click install and have the platform install it and run it for them. So the goal here is that OpenShift wants to have all the tools to be able to easily pull in whatever you need simply and easily. Databases are one thing, but what about a more complicated piece of software like Kafka? Installing Zookeeper and all the various other parts is sort of a pain. In OpenShift, it's a button click. I remember the processes that I used to have to do before something like OpenShift. I'd have to open a ticket for whatever I wanted, like Kafka. I'd have to explain the rationale of why I needed it, get my manager to sign off, submit the ticket, wait a few days. It really helped if I gave cookies to the operations team from time to time, but that's a different conversation. Half joking, but the Operator Hub is the centralized place where all of the pre-blessed vetted tools could be made available for me to install and use with a single button click. Red Hat also offers a number of supported languages and runtimes to be able to build the types of applications that you want. Having support means that you can rest easy knowing that the underlying language and the framework will all work as intended. And if not, you open a ticket, Red Hat engineers will make sure that it does. Or perhaps you have some complex business rules that business analysts can assist in modeling. So these model processes can actually be turned into execution component inside of a rules engine. You might have used this before, but if you haven't, this is just a modeling of some business process. Going a step further from the business model, with the help of a developer, you can automate a lot of the things, add human checkpoints to things. You can have dashboards where you're able to track how many processes are getting completed, or if they're not getting completed, where the bottlenecks are. this dashboard can give you real visibility into what's happening and what's not happening. So Red Hat Process Automation is the perfect tool to be able to accomplish all the things that I talked about. An application that doesn't communicate or connect with anything or connect with any other systems or anything else is in effect a silo. You build an application, nobody's using it, and it's not pulling data or it's not saving data, it's not connecting to another system, it's kind of not doing anything. So once you have more than one system working together, you introduce integration concerns. Maybe it's over HTTP, maybe it's some binary protocol open through some port. Whatever it is, you have two systems talking to one another, and you need to think about, really think about how they're communicating, how that connection and integration is going to work. Maybe two is not a problem, but as you expand your capabilities, that usually necessitates the involvement of more systems, making that integration challenge even more complex. And you got to solve this in the right way so that it can scale and grow with you, and you have resiliency in the connection between the systems. And that's where something like Red Hat has Fuse, which is a lightweight enterprise integration system. It's essentially, it's built off of Apache Camel, if you ever use that, which is the enterprise integration patterns book come to life with all of those, with a lot of those integration patterns, a whole bunch of connectors already built for you, vibrant ecosystem where you can get up and running and have those integration concerns easily solved for you, and have it all those integration pieces all in a nice, bring it to where those applications live and being able to connect them in a lightweight way. This is different, much different than an ESB. Potentially, if you're using an ESB, that's fine, but there are many different other weapons in that toolbox. Okay, so in addition to thinking about the integration using Fuse to integrate the different various applications, you can also have them more loosely coupled. You can have things like JMS Brokers or Kafka, an event streaming processing platform that can be used as an advanced event-driven advanced event-driven architectures. Okay, so out of the box, OpenShift also provides build capabilities to make deployment of applications in OpenShift as easy as possible. Of course, a build pipeline or something like that is preferred to get your, let's say, development branch into dev environments or your main branch into production. But if you're testing your application yourself and you want to run it in the cloud within OpenShift, and you want to use the OpenShift build functionality instead of having to build it on your laptop and push it up, that is an option. So OpenShift build actually supports a number of different ways to get your application into OpenShift. And that's done on purpose to be able to ease and make it as easy for you and work with your process as much as possible. So for instance, you can configure OpenShift build to look at a particular Git repo, and then it'll just pull it down, build the code itself by examining sort of what kind of project it is, maybe a job project, it knows to run Maven build, Maven package, Maven install, whatever. And then from there, it can package it up into a container and then deploy it for you. So pointing to a Git repository is all you need there. Or maybe you have processes already where you're already building an artifact. Maybe you're already building the war or whatever. You could take that and then send that to OpenShift, and OpenShift will then just do that last mile where it just packages it up in a container and deploys it for you. Or maybe you already have a process where you're already building a container. Well, that works too. You can just ship that over to OpenShift and it can deploy that as well. Now, a new feature added to OpenShift is this capability and this concept, this idea of native builds. Based off of the Tecton project, enables us to fully move the language of builds and build pipelines into OpenShift native objects. So this, what do I mean by native? It means we can treat the capability of building as part of the platform itself, as part of OpenShift. So this native integration has a number of key benefits, like only spinning up pods and consuming resources when builds are actually triggered. That means when nothing's being built, nothing is running, no resources are being used. Another great capability that I really like is this service mesh. Again, comes right out of the box. You install it through Operator Hub, and it's really super easy, and it's guaranteed to work with OpenShift. So there's a number of really awesome capabilities that a service mesh brings, like being able to put a bunch of different microservices together and get monitoring, tracing throughout the service mesh. You can get routing, ensuring the right services talk to the right other services, ensuring capabilities like mutual TLS so that traffic between the services are protected. You can have circuit breaking capabilities in order to be able to gracefully handle service failures. Chaos engineering so that you can artificially introduce failures in various service endpoints to test out your service mesh resiliency. So this service mesh, OpenShift service mesh offering is based off of Istio, if you've ever heard of that upstream project, but it provides, like I said, an easy way to pull that capability right into OpenShift, and it's added no extra cost. It's right from Operator Hub and it's guaranteed to work. Really great stuff. Next is serverless. So this is one I particularly like. Picture an application, again, that only runs when you need it. So this sounds familiar. I just talked about the native build capability with Tekton. If no one's using your application, there's really no need to run it. Have this concept of scale to zero, where if nobody needs it, it's not consuming any resources. So this is a pretty simple concept, but it's actually pretty tough to implement. If you actually look at the upstream project, Knative behind it, really simple to understand, but it's really powerful tool. It's often thought of as functions as a service. You might have seen AWS Lambdas or something like that, but this is actually bigger than that. It's actually more than that, because this is any containerized application can potentially be a candidate for a serverless application. So obviously, because it's being killed when it's not being used and then restarted when it is being hit again, that boot time is of critical importance. So you can't have any application. You can't have an application that takes minutes to boot, for instance, because that just won't work. But actually, so that brings us to our next topic, which is that boot time. How do we get applications to boot quickly? Talk about Quarkus here. So there's no secret that Java applications have a notoriously long cold boot problem, as well as a somewhat large memory footprint. So cold boot means starting from zero, starting from nothing. It's starting, you need to boot the Java runtime as well as your application. So there's some delay in that entire process, which is why in the past, having a kind of the serverless mentality with Java was a little difficult. But with the introduction of Quarkus speeds all of that up and makes Java not only viable inside of this technology, but also, actually a really good pick. So Quarkus, what exactly is it? So Quarkus is a Java framework that supports the Eclipse Microprofile 3.3, and is specially purpose-built to be fast and lean. So how does it do that? Well, a couple ways. One way is the first-class support for Graal, or the substrate VM, an extremely fast VM that supports native compilation. It also does some build time metadata processing where unused classes aren't even loaded in the JVM, and avoids reflection wherever possible. As you know, reflection is really slow, so we just go and try not to do it as much as we can. So I talked about native compilation. You can actually compile Quarkus down to either run on OpenJDK or down to native code. So this results in a much reduced memory footprint, starter fast up time, and smaller container images. You can see the numbers here. Quarkus native 12 megabytes over a traditional cloud native stack of 136 megabytes, for instance. So all this means is that Quarkus lets you use Java, your existing Java knowledge, to build serverless applications, or microservices, or just plain write faster Java apps. So the goal of the tools, I went through a lot of tools just now, but the goal of all those tools was really about giving developers the ability to architect and build the applications in the best way to solve their business problem. The added bonus is that if the solution is built on OpenShift with cloud native tools, it's more apt to be fast, stable, and scalable. All right, we've talked a lot about those developer-centric tools, but how do we make everything work together to get that code that's been produced out into a production environment? And for that, we'll look at pipelines. Okay, not all pipelines are created equal. Some pipelines build and deploy code, while others go even a step further to help ensure that the application being deployed is safe, secure, and is free from tampering. These extra steps that we add go a long way towards ensuring a workflow and pipeline where production deployments can be trusted and verified. But going from a basic pipeline to one of high trust is not something that you can instantly do. It's a culture shift with technology and process to support it. To make this shift, Red Hat has distilled years of industry knowledge and practice down into a proven and standardized approach anyone can use. Red Hat's trusted software supply chain is the process and automation tools to achieve high trust and compliance. We call this TSSC for short. It includes steps like unit testing, code quality assurance, security scanning, reporting, integration testing, deployment. You can think of this like a pipeline that carries water from one end to the other. In this case, we're carrying code. And just like a physical pipeline has filters that gradually improve the water, maybe filters out bacteria, whatever. In the same way, we have the same concept here where we have code being continually improved with steps along the way to be able to make sure that the output of one step is indeed the correct input to the next step. So the pipeline steps here, I just talked about them from a really high perspective, but we can take a look at the very specific concrete example here, such as static code analysis. You see that we generate some metadata and tag it. You can see the building stages. In this case, it's Maven running the build. You can see the testing stages, the static image scanning, the pushing of the new container image up to some registry, deployment. So we take all these steps together and we put them together in a trusted, high trust pipeline to be able to know that the thing that we deployed was actually the thing that we meant to build, because we can look through the artifacts that each one of these steps produced and be able to verify with a high degree of trust that this artifact is indeed the thing that went through this entire process and has all the compliance reporting that we need to be able to say, this is the state of this particular deployment. It passes all these tests, it fails these things, X, Y, and Z. So how exactly does this relate to how government agencies produce software? So you might have heard of this. This is the DoD Enterprise DevSecOps Reference Design, or DEDSWORD for short. So what exactly is DEDSWORD? I think it would help to understand the problem it was trying to solve in order to gain an appreciation for what it is. So I'm going to read a quick excerpt here from this executive summary of this document, so we can, I actually think it's really well written, so I'm going to read a bit here. Legacy software acquisition and development processes in the DoD do not provide the agility, to deploy new software at the speed of operations. In addition, security is often an afterthought, not built in from the beginning of the lifecycle of the application and underlying infrastructure. DevSecOps is the industry best practice for rapid, secure software development. The main characteristics of DevSecOps is to automate, monitor, and apply security at all phases of the software lifecycle. I think that's really, really well written. So, what exactly is DEDSWORD? So this is an excerpt from page 66 of this document. You can Google it and find it yourself. It's all public facing. There's another excerpt from that document I think that could shed light specifically on what DEDSWORD is trying to accomplish here. So the DoD Enterprise DevSecOps Reference Design provides implementation and operational guidance to information technology, IT, capability providers, IT capability consumers, application teams, and authorizing officials. Implementation and operational guidance. I'm highlighting that right now. So this diagram above is directly from DEDSWORD and describes in really good detail the steps of how to achieve an effective software factory. Actually, so these steps actually look very familiar to Red Hat's trusted supply chain pipeline steps, which I showed previously. DEDSWORD's at the top and our pipeline is at the bottom. Very similar, as it turns out. We can actually map the various steps from the DEDSWORD spec down to our own pipeline. And this isn't by coincidence. We've actually ensured that our trusted software supply chain is completely compliant with DEDSWORD. So being super creative as we are, we've named our implementation RedSword. I'll leave it up to you to figure out how we came up with that name. So RedSword doesn't prescribe DeadSword doesn't prescribe specific technologies, but instead prescribes workflows, processes, capabilities. Red Hat took those and made opinion implementation decisions, and that became the basis of RedSword. So RedSword is DeadSword realized. Even better, we are working to make it available via an operator. So we've talked about operators in the past, but it's a way to add capability and features easily into OpenShift or Kubernetes. But specifically in this case, we're talking about OpenShift. That means you can use the operator to stand up the entire DeadSword compliant pipeline yourself with very minimal steps. Now, I said before, you can't instantly have a high trust pipeline, but I think this is as close as I think you're going to get to that. And of course, all of our work is open source. You can go now to your browser, just look up for Plagios in GitHub. That's P-L-O-I-G-O-S. Okay, so you'll find a lot of great projects in there. Okay, so I've spoken a lot about developer tools and pipelines today, but what does this all really mean? Well, the one thing that I want you to walk away from this talk knowing is that OpenShift gives developers freedom and simplicity. Freedom and simplicity. The freedom to design and build applications the way that you want, using the tools you want, and the simplicity to be able to do that easily. This is just a quick sample of all the various types of applications that you can build on OpenShift, whether it be new serverless applications, traditional monoliths, high performance workloads, or AI ML. Go ahead and pick the right tool for the right job. Okay, most developers love to get their hands on stuff. So here you can go to learn.openshift.com where you can do some interactive tutorials, get a real taste, flavor, and maybe learn a thing or two along the way. Or if you want to play with it on your laptop, you can download this thing called Code Ready Containers. So we talked previously about Code Ready Workspaces, where you can have that IDE in the cloud. But this is Code Ready Containers. So the containers part is different, which actually performs a one-node install right on your laptop. So you can actually play with it right locally. And this works for Linux, macOS, and Windows 10. And lastly, this actually just came out a few weeks ago. If you wanted to play around with OpenShift in the cloud, specifically AWS, you could use this developer sandbox. It's a shared cluster. But because OpenShift is multi-tenant, it'll feel like you have an entire cluster to yourself. Granted, there are some limits. You can't run wild and run your entire production system on it. So there are limits like you only get 3 projects, 10 vCPUs, 8 gigabytes RAM, and only 14 days. After that, everything resets. But it's all free. There's nothing to install, and it's once you log in and you're able to get up and running pretty immediately. It's really easy, a really painless way to get started today. And that's it. That's all I had today. Hopefully you learned something. Hopefully it was fun. And Mark, back to you. Oh, Mark, I think you're on mute. Or I've been on mute for an hour.
Thank you, John. That was amazing. Really, the energy, the enthusiasm. We could tell you're a developer. You dated yourself a little with that cold fusion.
Oh no.
But really, I mean, it's the concepts that really resonate with a lot of the things that we're doing for our customers. I mean, this notion of speed, scalable, stability. I mean, can you just picture all contractors and stakeholders in GovCon out there? Yes, and yes, and this notion that DevOps is communicate frequently and empathy for teammates. I mean, that's life, right? I mean, I'm going to try that with my wife and see if that works. But really great stuff. Really exciting. Let's see what questions we have and try to maximize the time that we have left. So in your experience, what's the most effective way to demonstrate as quickly as possible the benefit of implementing a DevSecOps pipeline? And so just a little bit of color on this one, this is coming from an agency where they had just started on the path of DevSecOps and, announced some priorities, and they're moving forward and enabling DevSecOps, and some lessons learned there, or your thoughts on this would be very helpful.
Yeah, so let me recap the question. So the most effective way to Implement DevSecOps?
As quickly as possible. Demonstrate the benefits of implementing DevSecOps as quickly as possible. Quick wins, early adopters.
Yeah. So it's talked about before, but it's not a thing that you can instantly have, that high trusted pipeline, because of the implications that it brings, not only the technology, but the people and the process, and being able to move all of that in concert is tough. So to that question, I mean, it's excellent. You really want to demonstrate quick wins. So what are some things that you can do to immediately prove that value? Well, I'd say look at where you are today and see what incremental things you can add. If you have a pipeline today, great. If you don't, maybe the pipeline would be a first thing that you can have. So automating something in some fashion. Maybe you have a pipeline already. Maybe it's very immature, very in the early stages, where maybe it's just building, and then maybe you're manually deploying. Or maybe in that particular scenario, you could add tests. And then that could be the next thing you could demonstrate. You can say, hey, look, I got 100% test coverage. Like, oh, that's good. Yeah, it's this. And then the next build, maybe it has 90. And you're like, oh, okay, it's giving feedback. I know that there's something I can do here, right? So you want those tools to work for you. And so maybe it's already performing unit tests. Maybe the next thing is to add security scanning, or maybe it's to scan the containers. There are incremental things you can do to continually add capabilities to be able to incrementally put together this whole thing. And looking at the dead sort spec is a great place to start to see kind of what the high bar to shoot for, or looking up what Red Hat has put out in the Red Sword or TSSC. All great places to start to see where potentially your current process is lacking and where you can potentially find quick wins.
Excellent. Yeah, that's wonderful. And I just want to kind of add to that. Learn the Red Hat resource that you shared a little bit earlier. I mean, that's the tremendous amount of information up there. Our developers have been leveraging that for going on a year now, and we've really excited to kind of bring some of those benefits to our customers. So that's really great. Thanks for sharing. Next question here. This one's about scaling, John. So just kind of to set the stage for you a little bit. Part of this one's related to kind of how the Department of Veterans Affairs does business. And, one of the ways that development projects are kind of let out in the Department of Veterans Affairs, they have scrum teams. And so small, large, medium-sized scrum teams, and they're essentially optional CLINs, and the ability to scale is very important. And so this is a concept that's really on the forefront of people's minds. So as it relates to OpenShift, are there any scaling considerations? In other words, if there's a team limit where one DevSecOps pipeline, would it impact the velocity or the delivery or deployment as you scale up and add teams?
Yeah, that's a really good question too. So I'd say it really comes down to the particular business needs. So using an existing pipeline is great because you get a lot of benefits pretty much for free. You have all the hardening, all the tooling, all the process inherited already from this existing pipeline. If you can leverage that, that's a huge win, because that's now part of the idea of DevSecOps, where we're all working together to be able to collaborate and do more effectively. So that's a great option. But let's say maybe your process is more rigid, maybe it's different. Maybe you can't affect the change in the existing pipeline in the way that you need it to mirror how your business does business, how your group does business. Then potentially you might look at some other options. Maybe you do have to augment the pipeline in some way by standing up your own processes, your own pipeline. It's less than ideal because now you're having to do a lot of things over, and potential duplication, and maybe there's collaboration you can do so that you don't have to. But ideally, if you can leverage things that already are existing, that goes a long way, because now you don't have to think about it, right? You don't have to worry about it. You don't have to maintain it potentially. You just get to use it and go.
Excellent. Thanks. So this next one is security related. I particularly enjoyed the part of the presentation, the secure, trusted supply chain. That's really, really critical, and really another topic that's on the forefront of a lot of our customers' minds is continuous ATO and how they really get to enable that. And obviously, this would kind of be a piece of that. The Dead Sword and Red Sword discussions were definitely very interesting. Something we want to look into. Can you talk a little bit about Red Sword itself and its flexibility? And really, is it the tool driving the process, or is it the process driving the tool?
Yeah, actually, so you're not the first to ask me this question. I've actually heard this question before, because it seems so tool centric. Like all of these tools provide you the capabilities and the means to be able to perform all these things, but the real underlying thing that the tools are supporting is the process, is the people underneath. So fundamentally, that has to be the driver. You have to culturally want to work this way, to work together collaboratively, and you need the facilities in place already culturally to be able to do that, and then the tools support that process that you're doing. So really, it's about the process. It's about what you're doing, and if that's not working, then that needs to change so the tools can again support it.
Excellent, excellent. And you mentioned during your presentation Ploygos. That's the interesting name. What's the background of that?
Yeah, that's a really weird name. I made sure to spell it because it's really oddly spelled as well. But so there's actually a bit of history behind that. So Kubernetes, as you probably know, is helmsman, is Greek for helmsman. And so we took kind of that Greek idea, and so Ploygos is Greek for pilot. So in the same way a pilot would help you get somewhere, we want to help you get to DevSecOps and help you get to a trusted software supply chain. So pilot is where it comes from.
Okay, that's very interesting. Yeah, interesting. Good. Thanks for sharing that. Well, thank you so much. Today was excellent, John. I just kind of wanted to take a moment and thank you for all your time the last couple of weeks between the 101 session, giving us an overview, showing us a day in the life of operations, and then talking through a day in the life of development. I mean, this is really kind of where a lot of our customers are, and really just the back and forth between the operations and development and getting those to sync to really enable DevSecOps is really what we're doing for our customers right now. We are heavily involved with enabling DevSecOps and a number of different agencies, mostly in VA, Department of Veterans Affairs. And so we're really excited. We really appreciate your time. Government CIO looks forward to working with Red Hat and continuing this enablement of DevSecOps, not only in the Department of Veterans Affairs, but in other agencies in federal government. And stay tuned, folks out there, DevSecOps enthusiasts, stay tuned. We'll have another series coming up very shortly. We'll be having some roundtables and talking about DevSecOps. We'll be bringing on some very key strategic partners of government CIO, including the global consultancy of ThoughtWorks, to share some thoughts on DevSecOps, and they've actually authored some books on that as well, just like Red Hat. And we'll be bringing in folks like AppDiction Studios, which has done a lot of this platform enablement and DevSecOps enablement over on the Air Force side in Platform One and Kessel Run. So a lot of exciting things going on. Please keep tuning in. Check out Government CIO's Media and Research website for future DevSecOps events. And thank you for joining the Red Hat OpenShift series on DevSecOps. Thanks, John.